Okay, so what we will discuss for now is yung atin namang torsion. Torsion pa rin tayo, but this time, hindi na siya shaft or hindi na siya circular in shape, but hypothetically, in any shape, basta uh, manipis yung thickness. Okay? So, assuming, no? I'll try to draw. Okay. Example, I have here the shaft. Okay. Pero yung cross section niya, hindi lang binog. Okay, sabihin natin ganyan. Okay, syempre fixed 'yan. Okay. And then meron lang yung thickness. Okay. Para siyang hollow, pero this time hindi na siya bilog na. So in any form, so hypothetically in any shape. Okay. And then lagyan natin ng grid lines. Okay. Ito yung ating global x direction. Okay, so you have there the x. Okay. And then definitely meron tayong L. So at this L. And then meron tayong thickness. Okay. So you can have as the thick. Okay. Now, ang mahalaga sa torsion for thin-walled, ang tawag natin dito is torsion for thin-walled vessel. Okay. Thin-walled vessel. Okay. So yung thickness niya manipis yung masyado, no? Now, yung thickness niya, it runs through dun sa pinaka-median. Okay? So, parang gitnang-gitna. Okay, gitnang-gitna ng thickness. Okay, so may mapaform ka doon, isang closed loop. Okay? And then, try natin paikutin by a torsion T. Okay? Ngayon, yung effect ng torsion na yon dun sa body, mula dito sa free end hanggang dun sa pinakadulo is nagbabago-bago. Okay? So, kuha ko ng isa lang dito. Okay? Kuha ko ng maliit na block chan. Okay? Tapos, i-draw ko siya dito. Medyo papalakihin ko ng konti. Ano? So, kapag dinrawing ko siya, para siyang medyo naka-curve na ganyan. Okay? Ayan. And then, ayan, medyo curve na ganun. And then, syempre, meron yung thickness. Ano? Kumbaga, nag-cut ako. Yung part na yan, nag-cut ako doon, ano? So, since dun sa kinat ko, okay, 4 na edges yung nakatano. So, dito, mayroon ako ditong shear force or shear stress. No? Dito, meron din. Okay, hypothetical direction, meron ka din itong shear. Okay. Ngayon, dun din sa magkabila, ano, kasi, ano yan eh, tawag dito. Parang ganun, di ba? Oops. Yan. So, meron ka rin dong shear. Okay. So, may shear ka rin na paganto, and then may shear ka rin na paganan. Okay. So, dapat baliktaran. If this is towards to the right, yung isa is towards to the left sa likod. Okay? Para mag-equal sila. For equilibrium, dapat equal sila. No? Okay. Now, itong dimension ko na to, this is parallel to the x. Kaya lang, ang kinuha lang natin is sobrang liit. Okay? Infinitesimal length. So, since that is the x, that is the axis of the x, so I will call it as my dx. Okay? And itong pa-curve na to, okay, around the perimeter, kasi kumbaga, kung titignan nyo yan, parang ito lang yung part na yan eh. Okay, kung ipo-project natin doon, okay, ito lang yung part na yan, okay. Tawagin natin siya, yung buong yung buong perimeter is S, okay. So, we will call it as ds. Okay. So, dalawang direction, you have the X, and then you have the S, okay. Ngayon, yung shear stress natin, since it is this time i-introduce ko na yung concept ng tinatawag nating shear flow. Okay? So you have there the shear flow. The shear flow. Okay? So yung shear flow na yon, it runs through the midway or dun sa median line natin. I will call that as Q. Okay? Shear flow Q. Okay? Sir, saan ang ano yung shear flow? So, yung shear flow, meron kang shear stress. Okay? Kasi, di ba, para ma-multiply mo, para maging force yan, yung shearing stress mo, i-multiply mo by the area. But this time, imumultiply ko lang siya by the thickness. Okay? So, ito na yung magiging formula for the shear flow. So, you have there the shear flow, shear stress multiplied by the thickness. Okay? So, that's the first principle. And now, itatry natin ano. From this one, okay, since, okay, tawagin ko siyang, yung shear flow natin na to, okay, I will call it as Q. And then ito, I will call it as Q. Okay? Ngayon, itong nadagdag natin, yung shear natin sa magkabila, okay, pag inano natin yan, aside from the Q, okay, syempre may madadagdag kang shearing stress, ano? So, iyon is what you call the change in the shear flow with respect to the two axes. Unahin ko muna yung with respect to this axis sa dx. Okay? So, I will call that as Q, and then I will have it as partial derivative of shear flow with respect to x. And of course, yung length niya, and that is towards what you call the dx. Ito naman, kasi parang ang shear flow niya is in two direction, so you have here and then you have here also here. So ito ganun din. So you have here the Q, but this time this is the partial derivative of Q or the shear flow with respect, okay? With respect to S. Ano natin ano? Ay, nawala na yung ano ko. Okay. Medyo yan natin muna to, baba ko ng konti. So, oops, you have the shear flow, Q, and that is equal to shearing stress multiplied by the thickness. So, ito with respect to S, and then of course, you will have it as the ds. Okay? Now, we could say, since meron na tayong force, again, pag ganito yung X, pwede akong mag-summation forces sa X. So, summation ako ng forces sa X, and to be equilibrium, it should be equal to 0. So, ano yung mga nasa X ko? Okay? So, pag ganitong force, okay, etong part na to, and that is equal to Q plus partial derivative of Q with respect to S and then ds. Okay? And then I will be having here as minus Q, okay? And then multiply ako ng dx. Okay? So you can have it that way. Okay. This is not shearing stress, ano? Ano na to? I-multiply na natin siya by dx. Okay? Kasi shear flow lang to. Sorry. So, ito pala. Okay? Ito siya. Okay? And then, it should be multiplied also by the dx. Alright. Okay? Again, shear flow. Pag ganito. Pero ang length niya is the dx. Okay? Kasi diba, shearing stress, minultiply natin by the thickness, and then that would be the shear flow, and then multiply natin by length para maging force. So, force na to, and then minus yung pabalik sa likod. So, minus Q, again, you can have it as the dx equal to 0. Okay? So, tingnan natin. So, we can have it as Q plus partial derivative of Q with respect to S ds dx. Lipat ko sa kabila, so that would become Q and then dx. Okay? So, cancel si dq. Ano ang matitira? So, you have Q plus partial derivative of Q with respect to S ds is equals to Q. Ilipat ko sa kabila, so that is ts equals to Q minus Q. Ang Q minus Q equals to 0. Okay? What does it mean? Yung nadagdag na shear flow, okay? Yung nadagdag na shear flow for a circular, for a closed loop, okay, thin-walled vessel is constant. Okay? Ibig sabihin daw, ito daw, walang nadadagdag na shearing stress. Okay? Kapag nagka tayo ng section. So, this one is become 0. So, this means, yung Q natin would be constant all throughout the thickness and all throughout dun sa ating line. Okay? Dun sa ating length. So, ito, with respect pa lang dun sa perimeter, ano? So, check naman natin, submission tayo ng forces along the S. Okay? So, ganun din. Ito naman yon. So, I will be having here this Q plus partial derivative of Q with respect to X dx, pero multiply natin by the distance, that is your ds, is equals to Q multiplied it by the ds. Same procedure, we could also conclude, okay, parang kanina lang, simplification, this one, dx is also equal to 0. Okay? So, what does it mean? Again, so, yung additional, ito kasi additional to additional shear flow yan So, there would be no additional shear flow as you move from one point to another along the length and along the perimeter of the tube. Okay? So, or what should I say, that the Q for our example, okay, for a thin walled vessel is always constant. Okay? So, now, let's have the verification kung paano natin kukunin yung shear flow. Okay? So, for now, let's have first the copy. Okay? Medyo mahaba-haba yung ano. Okay? Sige po, copy muna. Okay. So, ituloy natin. And solving natin for the, what you call, shear stress. Okay? Torsional shear stress. Ano siya ilagay? Ay, ayun pala yung aking pen. Okay. So, balik ako. I-drawing ko yun. Okay. And then, sabi natin, so, assuming na nandito yung ating cross-section, I will call that as the point or the center. No? Tapos, again, we have here the median line. Okay. Tapos, kukuha lang ako ng infinitesimal length ng perimeter. Ano? So, eto. For example, simula dito hanggang doon, infinitesimal lang yan. So, that dimension, okay, I will call that as my ds. Okay? And then, syempre, meron ka ng shear flow dyan. Ano? Yung shear flow, kaya tinawag na shear flow yon para siyang nagfo-flow along that path. Okay? So, yan. Para siyang nagfo-flow na yan. Kaya tinawag na shear flow. Okay? So, yung shear flow ko na yon at this point, yung pinaka-center niya, para makuha ko yung pinaka-force sa kanya. Okay? Force speed, supposedly, pero dahil infinitesimal, I will call it as my dp. Okay? Makuha ko si dp, okay, para dapat meron akong shear flow which is constant and then multiply it by the ds. Okay? Now, if I will take the moment para maging torsion shock, I will take the moment from here. Okay? So, kuha ko, assuming na that is perpendicular, no? Dapat kasi perpendicular yon. And then that would be the r, or the distance from the center papunta doon sa ating median line. Okay, so I will call it r. So that I will be having here yung moment niya, dp, or the force, multiplied by the distance r. Okay? Or, that would become equal to q, r, and then ds. Okay? But remember, we need to integrate kasi yung nakuha natin na to, infinitesimal lang siya at the length ds. Ang kailangan natin is buong perimeter. So, ano ginagawa natin para makuha natin yung torque na yon or yung we need to integrate it. Okay? So, since this is a closed loop, I will have that circle on the integral side. Okay? At the ds. Okay? So, I have now the t torque is equals to integral of q, r, and then ds. Okay? So, this is actually already the torque. Okay? Kaya lang, alamin natin, no? So, kasi syempre, hindi natin kailangang i-integrate yan. Okay? Now, kung kukunin ko yung area mula dito, baguhin ko yung kulay. Ito, no? Kunin ko yung triangle na yan. Yung triangle. Tapos, kukunin ko yung area na to. Okay? Dahil infinitesimal yan, I will call it as supposedly A sub O. Okay? Yun kasi dapat yung A sub O, yun yung area na bounded ng ating median. Okay? So, yung buo dapat na yun. Okay? Buo. Ang problema, infinitesimal pa lang tayo. So, I will call it as dA. Okay? So, yung area lang na yun. Okay? Also, mapapansin natin, since this is a right triangle, I could also say na yung area na to, which is the dA, which is also equals to 1/2 base times height. So, ang base ko is ds at ang height ko is r. Okay? So, what does it mean? 2dA sub O, or infinitesimal area, is equals to ds multiplied it by r. Okay? So, I'm trying to say na kapag pala binuo, okay? Kapag pala binuo ko to, kasi i-integrate ko okay? With respect to the s. Ito, mabubuo na rin siya. Matatanggal na yung aking d. Okay? So, ibig sabihin, that would become 2a sub O. Sir, nasan yung 2a sub O na yon? Ito na yon, yung buong area enclosed by this line. Okay? So, yun yung buong area niya. Yun na yung buong a sub O. Okay? That is actually your a sub O. Okay? Ngayon, yung 2a sub O mo, again, that would become equals to, this time, that would become, dsr integral of s. Sa substitute ko dun, okay, I will try to substitute that. So, my torsion would now become equal itong integral of s r ds. Ito yun, that is 2a sub o. So that I can now have q multiplied by 2a sub o. Okay? Now, yung shear flow natin, okay, kasi ano ba ang naging formula natin? Solving for q, that would become t all over 2a sub o. So now, you will now have this formula for the shearing stress. Okay, shear flow, sorry, for the shear flow. So you have there the torsion, okay, on the body, o yung given, madalas yan yung given. And then again, A sub O, this is the area enclosed by median line. Okay? So, yung center. Okay? So, we will now proceed more on the, if you have question again, you may type, okay, or you may raise your concern. Okay? So, you will now have the concept of the shear flow. Now, aside from that, aalamin din natin syempre yung rotation. Tama ba? Kasi laging ganun na mahalaga sa atin eh. The stress as well as the deformation. Okay? So, for now, I'll try to delete total na copy na to. I have given enough time to copy for this one. Oh. Yan. Okay. Now, ang kailangan ko, again, ibalik ko yung kanina. Oh, okay. Oops. Okay. And then, again, nasa na ngayon? Ito yung ds. Okay. And then, of course, this is my dx. Okay. Now, dahil papalipitin ko siya, okay, pag pinalipit ko siya, may tendency na itong line na to mapunta dun. Ayan, para magiging ganyan ano. And, i-drawing ko lang yung supposed D. So, deformation niya. Yan. So, nakita niya, no? So, nung pinalipit na ganon, because of the shearing force. Diba may shearing force yan? Dun, tinutulak. Okay, so, na-deform siya. Okay? Now, yung deformation na yon, okay, yung angle na nandito, again, tatawagin natin siyang shear strain. Okay, sabi ko nga, ano yung shear strain? Diba? Para lang siyang tangent. Okay. Now, yung distance natin na to, okay, ito rin yun, ano? Ito rin yun. So, kumbaga, yung side na to, para makuha mo siya, you will be having here, parang, ano ba? Tangent? Hindi. Tawag dito. You will be having here the dx multiplied it by the shear strain. Okay? So, itong line na to, kinuha ko lang to, okay, and then I multiply that. So, using the tangent function. Pero sabi nga natin, di ba, before, kapag yung angle mo ay sobrang liit, so yung tangent mo, nawawala. Okay, so kumbaga, I can have it, kasi this one, supposedly, that would become dx tangent of gamma, no? Kaya lang, sobrang liit ng angle mo na yon, so ito, naka-cancel out. So, that would become dx multiplied it by the shear strain. So, yun din yun. Okay? So, delete ko na lang. Sige na, mamaya na. Okay? Now, para makuha natin naman yung deformation niya, we need to account to tinatawag nating work done. Okay? May internal. Okay? Parang ginamit na natin yan. No? So, dapat yung work done na nagagawa ng internal force mo, it should be equal to the work done na nagagawa ng external force mo. Okay, so ano ba ang formula ng work? Okay, so sige nga, di ba yung work natin, that is 1/2 force multiplied by the distance. But this time, yung distance, it should not be perpendicular, no? Kasi magiging moment yun. It should be parallel to the force. Okay, so now, Yung force natin, work done, 1/2. Again, nasan yung force natin? Yung force natin na na-create, that would be the Q multiplied it by the ds. Ito yun ano. So, Q, meron ka kasi dyan Q, and then multiply it by the ds as the distance. So, you can have it as 1/2, and then Q ds, that is the force, and ito yung distance mo. Okay? So, ito kasi yung force mo na to, Q, pero this is a shear flow. So, kung shear flow siya, kailangan i-multiply ko by length. So, you will have it the ds. Ayun po yun, yung QDS. Okay? And then ito, that is the distance nang na-travel, okay? Nang na-travel nung force na yun. Okay? Or yung displacement. Parallel to the force. So, ito yung parallel nun. So, you can have it as gamma. And then, you can have it by the dx. Now, since this is infinitesimal, pare-parehas, yung work natin, I will call it as also infinitesimal work. So that you can have it as 1/2 Q ds multiplied by the gamma multiplied by the dx. Okay? Ngayon, di ba? Na kung natatandaan nyo yung ating stress and strain diagram, okay? Balikan ko lang. So you can have it the strain. Okay? And then you have just the stress. And then yung pinaka-Hooke's law natin, di ba? Yung E, ang tinatawag natin yung E, it's the slope of the line, of the straight line, ano? So, you can have it as sigma n over the strain. Ngayon, since we are talking about the shear, papalitan natin siya. So, instead na E, gagawin natin G, or shear modulus. Okay? And then, ito, instead na normal stress, magiging shear stress na siya. And this one, instead na strain or normal strain, magiging shear strain na siya. Okay? So, you have that principle. Now, yung from here, yung Q natin, yung shear natin, okay? Di ba meron tayo kaninang shear flow? So, yung shear flow natin is the shear stress multiplied by the thickness T. Okay? So, solving for T, solving for shear stress, that would become Q all over T. So, that it will become equal to Q all over T multiplied by the lambda. Okay? So, solving for that, shear strain, so that would become Q all over T multiplied by the G. Okay? Ngayon, ibabalik ko dito sa du. So, I will be having here the du. Okay? Substitute 1/2 Q and then ds. This time, yung pinaka shear strain ko or yung aking lambda, so you can have it as Q all over T multiplied it by G and then multiplied it by the X. So, pwede kong pagsamahin, ano? So, I can have du. Ito, delete ko na. So, here, I can now have the du. Okay? Equal to Q, and then that would be Q squared. Okay? So, you can have it as Q squared all over 2TG. So, you can have it as 2 GT. Sige, 2 dGT. And then you can have it as dx and then multiply it by the dx. Again, this is the infinitesimal with respect to the x and with respect to the s. Now, kailangan makuha ko si u. So, I need to integrate that. No? So, i-integrate ko yan parehas para makuha ko si u. Kaya lang sa kabila, kung mapapansin nyo, dalawa yung ating variable. We have the s and then we have the x. In short, we need to, what you call this one? Ay, nawala yun to. Ayun pala. So, it means we need to integrate it twice with respect to x and with respect to s. X and then s. Okay? Pero ito, since this is constant, pwede ko yung ilabas. So, I have here q squared all over 2g and then t. Okay? Now, i-integrate ko muna with respect to L para sa dx. Okay? And then, itong ds, again, kailangang i-integrate ko rin siya with respect to s. And then, you can have it as ds. Okay? Ito, ipasok ko na, no? Kasi yung ds niya, may kinalaman sa t. So, ito pala. Sorry, ipasok ko to. Okay? I will have that all over t. Okay? And then, you can have it as your dx. Okay? So, ito na yung magiging pinaka-work done natin galing ng internal force. Now, if we are going to have it integrate here, okay? So, magiging ano yan eh, q squared all over 2g and then integral from s ds all over t. Again, that would become x integral from 0 to L. Okay? So, palitan ko yon. So, ang u natin, yung palitan ko yung x ng L. So, you can have it as q squared multiplied it by L all over 2g. Okay? And then again, integral of ds all over t. Okay? So, ito na yung ating form or ito na yung ating tag dito, work done by the internal torque. Okay? Now, or internal force. Ngayon naman, we will be having the work done by external. Okay? Now, again, you can have it as u equals to 1/2 force times the distance. So, yung force natin, that is actually the torque itself. Yung distance niya, syempre, yung dami ng nag-rotate. Okay? So, we can have it as theta. We will call it as the theta. Okay? Yun yung hinahanap natin eh. Yung rotation eh. Okay? Or, ayan, meron na pala ako dito. So, it means, pwede ko na silang ipag-equate. Kasi sabi natin, the work done by internal should be equal to the work done of the external. So, I can have it as q squared L all over 2g and then integral of s ds all over t. This is the internal and then the external, that would be 1/2 t multiplied by the theta. Okay? Now, sige, i-delete ko muna to. Ay, sorry, nakapin na ba? Sige. I'll find time para i-copy nyo muna yung the rest. O, di ba nakikita nyo kung saan ginagamit yung mga DE nyo? May nagtatanong sa akin, hirap-hirap daw ng DE, hindi naman ginagamit sa tunay na buhay. So again, in deriving those formula na meron tayo, dun galing. Dun yung, yun yung proseso, no? Okay, so let's continue. Okay. So, kunin ko na si Theta. Okay. Para I will be having here yung Theta natin. So, you can have it as, oh, wait. Q squared. Q squared L all over, ay, nasa na A sub O? Ayun, okay. We need to plug in the Q. Nasa na yun? Na-compute na natin kanina yon. Yung may A sub O. Ay, na-delete ko yata. Teka, isa pa. Yun. Okay. Kaya pala hinahanap ko. Hindi ko makita. So, dito ko muna lagay ang T all over 2A sub O. Yan. Saka natin delete. Okay. I'm going to plug that in dun sa ating Q. So, pag plinag in ko yon, Q squared, so that is T all over 2A sub O squared, no? And then yung natira, L all over 2G. And then integral S ds all over T is equals to 1/2. And then you multiply it by T and then by theta. Okay, we need to find for the theta. Okay, so kunin natin si theta. So I can have it. Ito, pwede ko nang gawin yan na T squared all over 4AO squared, no? Ayan. And then L all over 2G integral of S ds all over T. Ngayon, i-multiply ko to by 2. Ilipat ko dun yung 2. Okay? And then, ibaba ko yung T dito. So, ibaba ko yung T doon. Ayan. Para maging theta na lang siya. Okay? By the algebra. So, cancel ito. And then, cancel yung 2. So, we can have as T, L, all over 4G, A sub O squared. Integral of S, ds all over T. So, ito yung ating rotations. Okay? Kaya lang, how about this one? This term. Okay? So, again, para lang naman yan, changes. Okay? Parang, sinasabi niyan is the change of the perimeter kapag lumiliit or lumalaki yung thickness. Pero, kung constant naman yung thickness mo all throughout the line of the S, and then this one would become equal to S. Again, you should have the constant T. So that would become T, L, and then that would become S all over 4G A sub O squared. And that would be the rotation that we are looking for. Okay? So this now becomes the formula for the rotations. Okay? So dalawa lang naman yung kakabisuduhin natin. That would be the flow. And then we have here the rotation. Okay po? Sige. Find time to copy. Okay, so let's have the problem. First problem. The constant wall thickness of a tube with elliptical cross-section shown is 0.12 inches. What torque will cause a shear stress of 6,000 psi? Okay? So, again, yung ating pinaka shear flow na tinatawag. Okay? So, constant naman yung cross-section area, so we don't need to integrate. Okay? So, yung pinaka shear flow natin, yun. Tama. Okay, yung pinaka shear flow natin, shear flow Q. Kaya ang formula niya is T all over 2A sub O. Okay? So, from the formula of torque. So, dinerive natin yan kanina. So, we can have the shear flow. Okay? And then, we can have it the shear stress. Okay? Yung shear stress natin, para makuha natin, that would be the shear flow divided by our thickness. Okay? Since constant naman yung ating thickness. Okay? So, hindi natin kailangan mag-integrate. Okay? So, sa substitute lang natin yung ating shear max. Okay? So, yung Q natin, okay, so this term, okay, substitute natin dun. Okay? So, we can have it as shear is equals to, yung Q natin, papalitan ko, that would become equal to T all over 2A sub O. Okay? And then, I still have the T there. So, this would be our formula. Okay? So, na maximum natin, sabi that is 6,000. Okay? Again, the unit is in PSI. Okay? Now, ang hinahanap natin is what value of T actually, no? So, we can have it as our T all over 2A sub O. So, ang A sub O natin is the area of the median. Okay, kung titingnan natin yung median natin, ayun siya, no? Okay. Sa gitna. Since this is an ellipse, okay, ang formula ng A sub O natin, okay, lagay ko dito, is actually pi AB. Okay, so this is area of ellipse. Okay? So, nasan dyan yun? So, from the center, ito yung center natin. Yan. Okay? This would be one value. Tigkakalahati lang, ano? So, ibig sabihin, we can have it the A, which is equals to 3 inches. And we have here the B, which is equal to 1.5 inches. So, this is your A, and then this is your B. So, yung ating A sub O, so that would become pi multiplied by 3 and then multiplied it by 1.5. Okay, so lagay ko doon yung A sub O ko, that is pi times 3 times 1.5. Okay, and then of course the thickness is 0.12. Okay, so I have now here. So, to solve for the value of T, that would become equals to 6,000. Okay, multiply ko lang doon, ano? Multiply it by 2, pi, 3, 1.5, and then 12. Okay? So, you have now here the resulting torque. So, that's 6,000 times 2 times pi times 3 times 1.5 times 0.12. Okay? So, you can have it as 20,357.52. Again, the unit would be ang ating torque, this is in pound. Okay, kasi pound yung ating PSI and then inches, so you can have it as pound inch. Okay, so this is now your answer, okay, for the question. So that is the required torque para magkaroon ng shear stress na 6,000 PSI. Okay po. So, sige, let's try to copy first. so let's continue for the second problem. A steel tube with the cross-section shown carries a torque T. The tube is 6 feet long and has a constant wall thickness of 3/8 inch. 1. Compute the torsional stiffness K. That's the torsional stiffness, that is the measurement of the stiffness. Parang in layman's term, kung gaano katigas or ka-strength yung isang bagay. So, meron tayong tinatawag na actual stiffness. So, meron tayong tinatawag na torsional stiffness. So, for the torsional stiffness, that is K equals to torque all over the theta. Okay? So, it is just the ratio of the torque and then of over the theta. So, what does it mean? Mentrans mas malaki yung torque na kaya niyang dalhin, okay, nasa numerator siya, ibig sabihin malakas yung stiffness niya, okay? Or, mentrans mas maliit yung nade-deform sa kanya kapag ina-applyan ng torque, nasa denominator siya, so it means indirectly proportional siya dun sa K. So, mentrans lumiliit yung theta, lumalaki yung stiffness. Mentrans lumalaki yung kaya niyang dalhin T, torque, malakas yung kanyang stiffness. Okay? So, again, in layman's term, pag sinabi natin torsional stiffness, parang iyon yung lakas ng isang bagay. Okay? Parang measurement siya ng lakas, ano? So, the formula for that is T all over theta. Okay? So, second question, if the tube is twisted through 0.5 degrees, so, naka-degrees, ano? Hindi naka-radian. So, determine the shear stress in the wall of the tube. Use shear modulus equals to 12 times 10 to the 6 psi and neglect concentration at the corners. Okay? So, kasi nga, hindi kagaya ng mga pipe, dire-diretso yung shear flow niya. Hindi, dito, kapag kasi, kuwari yung shear flow mo, oops, may kanto, no, nakantohan. Okay, bago siya nag-move on the other side. So, merong stress concentration dun sa corner. Pero hindi natin pag-aaralan yon dito sa ating mechanics of deformable. So, maybe pag-aaralan yon sa numerical, okay? Pag siguro graduate na kayo, pag nag-take kayo ng master's degree. Okay? However, okay, let's proceed. So, matatandaan natin, no? Kinompute natin kasi ang kailangan natin is makuha yung theta or yung K. So, una, meron tayong formula muna. Okay, yung formula natin for the theta. Ano ngayon na-compute natin? We have T, L, S, all over, we can have 4G A sub O squared multiplied by T. Okay, so we're in the T is the torque, the L is the length of the member, the S is the perimeter of the median. Okay, then the G is the shear modulus, A sub O is the area of the median, and then the T is the thickness. Okay, so sabi natin, to solve for the K, that would become T all over the theta. Okay, so yung K natin, so we have here the T all over, ang theta natin is T L S over 4G A sub O squared of T, no? So this would become equals to T. Okay, ang ginagawa natin, pag nagde-divide tayo ng fraction, paano? Nagpo-proceed tayo sa multiplication, pero tinitake natin yung reciprocal ng denominator. So, we can have it as 4G A sub O squared T all over T, L, and then S. Okay? So, as we can see, na-cancel natin yung T. So, that ang ating K stiffness is equals to 4G A sub O squared T all over L, and then S. Okay? But before we could get that, kunin muna natin yung A sub O. Okay? Again, ito yung median niya. Okay. I-drawing natin yung median, ano? Okay. So, para siyang, okay. Ayan. Lagyan natin yung dimension. So, this is a trapezoid. We can have it as 6. We can have it as 4. And this distance is equal to 5. Okay? Or, since 4 to and then 6 to, yung magkabilang side, it already measures 1 inch and then 1 inch. Okay? So, to solve for the A sub O, and again, area of a trapezoid, 1/2. Okay, base 1 plus base 2, multiplied it by the height. So you can have it as 1/2. Ang base 1 natin is 4 at ang base 2 natin is 6 at ang height natin is 5. So we can have A sub O equal to, where's my calculator? Yun. So 1/2 4 plus 6 multiplied it by 5. So we can have it as 25 inches squared. Okay? How about the perimeter or the S? So we can have it as 6 and then we can have it as 4. Tapos, dalawa nung side na to. So, ita times 2 ko na lang, ano. Kaya lang yung 2 na yan, para siyang, ito meron kang 5 eh. Parang hypotenuse ng triangle, ano. So, we can have it as square root of, so we can have it as 1 squared plus 5 squared. Okay? So, you can have this one. 6 plus 4 plus 2 square root of 1 squared plus 5 squared. So, you can have it as 20 inches. Okay? So now, pwede na natin siyang isolve. Okay? For our K. So we can have it as 4. Again, naka-PSI. So everything should be in pound and everything should be in inches. So we can have it as 12 times 10 to the 6. Okay? 4 times, where is that? Ito na tayo, no? So we can have 4G and then A sub O squared. So we can have it as 25 squared. And then multiply it by T. Ano yung thickness natin? 3/8 inch. Okay? All over, we can have it the length. Yung length natin naka-feet. So we need to convert that into inches. So we can have it as, oops, sorry. We can have it as 6. Huh? Wait. Ano nangyari? Hindi ako makapag-drawing. Ayun. Ah. Nasa na yung menu? Yeah, ayaw. Okay. Wait for a while, ha? Hindi ako makapag-drawing eh. Okay, ayun, nakita ko na. So, balik. L. So, we can have it as 6 multiplied it by 12, no? Para maging inches lang siya. Okay? And then, we can have it the S. So, yung S natin, we have 20.20. Okay? So, ang K natin, we can have it as 4 12 times 10 to the 6 times 25 squared times 3 all over 8 all over 6 times 12 times 20.20. Okay? So we can have it as 7 iyan ako, no? 7.735 times 10 to the 6. Sir, anong unit niyan? Okay, check natin ano ang unit ng torque natin. So again, everything is in pound, everything is in inch. So we can have it as pound and then inch. Pero, okay, since we use the computation, pag kinahalo nyo po sa computation ang isang angle, okay, naubusan na po ng disk space. Anyway, okay, balik ano? So ano yung pinaka-unit natin sa baba, no? Kasi theta, okay? Remember, if you are going to have the theta, or kapag ginagamit nyo yung theta sa multiplication, division, tapos wala siya sa loob ng trigonometric function like sine, cosine, tangent, dapat yung theta nyo laging naka-radian, okay? Pero kapag nasa loob siya ng sine, cosine, tangent, okay lang yon na naka-angle, okay? So, it means dito sa formula natin, okay, dahil kahalo siya, so yung theta natin is outside the trigonometric function, so the unit for that should be in radian. So, in short, ito should be in rad. Okay? So, you can have this one. Pero kung gusto niyo siyang i-convert into, so okay na yan, you can have this answer. Okay? Or, if you want to convert it, okay, so ano nga yung ano natin? Conversion natin? Sa 2 pi, meron ka, sa 2 pi, meron kang 360. Or, sa isang pi, meron kang 180. So, that yung K mo pag multiply natin yan by by pi all over 180, you can have it as 135.00 times 10 to the 3. Again, that would be pound inch, this time per degree. Okay? So, either of the two, okay, either of the two, unless ibigay ko yung unit in pound inch per degree. Okay? So, that is already the solution for that. Punta tayo sa number 2. Ano yung number 2? Determine if the tube is twisted through 0.5 degrees. Determine the shear stress in the wall of the tube. Okay, now, to have the K from this formula, okay, meron na tayong K eh. Tapos, given naman yung angle. So, we can have it as our T. So, ang T natin, that would be K multiplied by theta. Ang K na gagamitin ko, since naka-degree na siya, ito na ang gagamitin ko. Okay? Na K, para naka-degrees na siya. So, you can have it as 135 times 10 to the 3. Again, pound inch per degree. Okay? And then, multiplied it by the theta, which is 0.5 degrees. So, cancel yung degree. So, the unit of the torque would now be in pound inch. So, that is times 0.5. Okay, so you can have it as 67.5 times 10 to the 3. Again, the unit would be the pound inch. Okay? And to solve for the shear flow, okay, kasi bago natin makuha yung shear stress, kailangan natin yung shear flow. To solve for the shear flow, okay, which is that is equal to Q, that would be T all over 2A sub O. Okay? So we can have it as 67.5 times 10 to the 3. Again, that is in pound inch all over 2 multiplied by A sub O. So we can have it as 25 inches squared. So cancel yung inches squared, cancel yung inch. Ano unit natin? That would be now in pound per inch. Okay? So you can have it as 67.5 times 10 to the 3. 2 multiplied it by 25. Okay? So you can have it as 1,350.04. Again, that is pound per inch. Okay? And lastly, to solve for the shear stress, okay, so we can have it as Q all over the T. So we can have it the Q, that is 1,350.04. Again, that is pound per inch. And then we divide it by the constant thickness T, which is 3 all over 8. Again, this is inch. So the resulting is pound per inches squared, or PSI. So divided by 3 all over 8. So you can have it as 3,600.10. Again, that is in PSI. So this is now the answer for the second problem. Okay? So again, ang mahalaga dito, you have the concept of decay. Okay? So which is T all over the theta. And then the rest has been discussed to us earlier sa mga formula we just applied. Okay po? So sige po, kopya for a while. So let's have the next problem. Okay. An aluminum tube, 1.2 meter long, has the semicircular cross-section shown in the figure. If the stress concentrations at the corners are neglected, determine 1. The torque that causes the maximum shear stress of 40 megapascal, and 2. The corresponding angle of twist of the tube. Use G equals to 28 gigapascal for aluminum. Okay. So, this time, hindi na constant yung thickness ng ating tube, ano? Merong 2 mm, tapos sa baba, merong 3 mm. Okay. However, yung median niya, okay, semicircular siya na 25 mm yung cross. 25 mm yung radius. Okay? So, again, to solve for the Q, okay, ano yung formula natin for Q? Okay. And we have Q equals to shear stress multiplied it by the thickness. Okay. So, meron tayong shear. Okay, ang shear natin is 40 megapascal. Okay. Ngayon, ano ang gagamitin mong shear, anong gagamitin mong thickness? Okay? Again, kung papansin natin yung formula, mentras mas maliit yung thickness mo, mas lumalaki yung shear stress mo. Okay, they are indirectly proportional. So, it means mas malaking thickness, mas maliit na shear stress. Mas maliit na thickness, mas malaking shear stress. Okay? So, to produce the maximum shear stress of 40 between the two of 2 mm and 3 mm, yung 2 mm yung gagamitin natin. Okay? So, we will use the 2 mm. Okay? So, this one is 40. So, 40 megapascal times 2 mm. So, ang unit natin dito is 40. By the way, no? This one, okay, para di kayo malito, 40. And then again, Newton per millimeter squared. Okay? So, and then you can have it as 2 mm. Okay? And that would become 80. Again, that is Newton per millimeter. Okay? O kung gusto nyo gawing Newton per meter, multiply natin. So, 1,000 mm in 1 meter. So, cancel yung mm. So, you can have it as 80 times 10 to the 3. Again, this is now Newton per meter. Okay? So, you can have that. Now, for the A sub O. Sabi ko nga, yung A sub O nyan, okay, bagay yung kulay, para lang siyang semicircle. Okay? So, area of the semicircle is 1/2 pi r squared. Okay? So, you can have it as 1/2 kalahati ng area ng circle. So, 1/2 pi. And then, ang r natin is 25 mm. And then, you can have it as squared. Okay? So, where's my... So, you can have it as 0.5 of pi multiplied by 25 squared. So, you can have it as 981.75 mm squared. Okay? Now, to solve for the T, okay, kasi sabi natin, ang hinahanap natin is the torque that could create the maximum shear stress of 40 megapascal. So, from the formula, T is equals to 2 A sub O multiplied it by Q. So, again, ang gamitin na natin, okay, we can have it as 2, since ang A sub O natin is naka-mm, 81.75 mm squared. So, dapat ang shear flow natin naka-mm din. So, ito muna gagamitin ko, ano? So, you can have it as 80 Newton per mm. Okay? So, cancel yung mm. So, ang resulting unit is Newton millimeter. So, you can have it as 2 times 91.75 times 80. So, you can have it as, ayun, masyadong mataas, ano? 157,079.63. Again, this is in Newton millimeter. Okay? To convert that into Newton meter, so meron tayong 1,000 millimeter. So, 1 meter. So, cancel si millimeter. So, divide natin by 1,000. So you can have it as 157.08 Newton meter. Sir, kapag po ba sa exam, Newton millimeter yung sagot, okay lang po? Yes, okay lang, no? Unless otherwise, banggitin sa problem na the torque should be in Newton meter. Pero kung wala namang nabanggit, okay na yung Newton millimeter. Or okay na rin yung Newton meter. Whichever is convenient para sa inyo. Okay? So, next. The angle of twist. Okay? Yung angle of twist may kinalaman, ano? Hindi na natin pwedeng basta-basta gamitin lang yung pinaka TLS all over 4GA squared T. Okay? Kasi that is for the constant T. Okay? Instead, what we will use, okay, I'll change ulit. So, for the theta, gagamitin natin TL all over 4G A sub O squared. And then, that is the integral of the S. ds all over T. Yan. Naku, mag-i-integrate ba tayo? Hindi naman. Okay? So, what we will try to do is isi-simplify natin yung term na to. Okay? So, parang ang magiging simplification niyan is integral ds para sa 2mm, so 1, and then additional ds all over t para sa second, para sa 3mm. Okay? So, ano yung s nun? Okay? Yung S para sa 2 meter is yung kalahati lang na to. Okay? So, ano ba yung kalahati nun? So, we will be having, ito lang pinag-uusapan natin, ha? So, we can have it the ds all over t. So, yung S para sa 2mm is kalahati ng perimeter. Okay? So, ano ba ang perimeter is 2 pi r. Okay? So, 1/2 of 2 pi r. And then, sa susunod, ito naman ano? So, plus 2r. Ito pala ay over thickness ng 2mm. Ito ay ang thickness ng 3mm. Okay? Saan nanggaling yung 2r? Yung isang r kasi, dalawa sila. Papunta dito, tsaka papunta doon. Okay? So, you have your 2r. So, that would become equal to 1/2. Palitan ko na to. Palitan ko na yung R natin. Palitan ko na ng 25. And this one, palitan ko na rin ng 25. Okay? So, ano ang ating... Okay. Ito na yung integral of S ds all over t. Okay? So, you can have it as 0.5 2 pi r all over 2 plus 2 times 25 all over 3. Okay? So, you can have that equal to 55.94. Again, the unit would be in mm. Okay? So, isa-substitute natin ngayon dun. So, to get for the theta, the whole theta, okay? Dito ko na nalalagay. We can have it equal to the t. Okay? Ang t natin, again, that is in Newton meter to. Okay? So, ang gawin natin, lahat gagawin natin in millimeter. Okay? So, para maging consistent tayo. So, etong gamitin natin para millimeter na tayo. So, we can have it as 157,079.63. Okay, again, in Newton millimeter. And then, ang L natin is ilan? 1.2 meters. So, gawin natin 1,200 mm. Okay? All over. Okay, so 4. And G natin, again, para maging Newton millimeter, gawin natin megapascal, 28,000. Okay? And then A squared, A sub O squared, ito, no? 981.75. Okay? And then, syempre, i-multiply natin. Okay? Multiply natin to. So, lagay ko doon. Oops, delete ko to. Okay, multiply by 55.94. Okay? So, you can have it. The angle, again, that would be in radian. So, check. 157,079.63 times 1,200 all over 4 times 28,000, 981.75 squared, and then multiplied it by 55.94. So you can have it as 0.0977. O gawin natin 5.8. Okay, sige. But this is in radian. Okay? So to convert that into degrees, so we multiplied it by 180 degrees in 1 pi. Or you can have it this one. 180 divided by pi. You can have it as 5.60 degrees. This is now the angle of twist. Okay? What happened here? Yung dahil hindi constant yung thickness natin, tinake natin as parang summation siya, no? Summation ng S all over T for the one thickness and another S over T for the second thickness. Okay po. So that's the solution for that problem. If you have questions, so you may raise it or you may reach me. The next topic will be the flange bolt coupling. So, para rin siyang torsion, ano. Imagine din nyo na lang, you have here the two pens na pinagdikit. Okay, para mapagdikit yun, nilalagay nyo ng plate. Okay, tapos, nilalagay nyo ng bolt sa gilid. Okay, parang itong nakikita nyo. Okay, so meron tayong plate, tapos may nagko-connect sila ng mga bolts. Okay, now, yung torque na yun, okay, pagtutulong-tulungan yun, paghahati-hatian nyo ng lahat ng bolts. Okay? So, with this, kailangan alam nyo kung nasan yung pinaka-centroid ng bolt. Okay? So, alamin natin nasan yung center ng bolt. Okay? And then, kada isa from the center of bolt, okay, kukuha yun ng perpendicular distance, parang tangent doon sa kung saan man siya. So, yung point of tangents na yun, magkakaroon doon ng force. Magkakaroon yun ng force doon, and you will have as P. Okay? Again, ang nagre-resist doon is yung shearing stress ng bolt. Okay? And then you multiplied it by the area of the bolt, of course. No? So, or since ang bolt is circular, so you can have it as shear multiplied it by pi over 4 multiplied by d squared. Okay? So, para sa isa yon. Ngayon, para dito, ganun din. Kuha ka dito, tangent C. And then, yung pinaka-tangent doon, which is 90 degree yun, again, that would be another P. Okay? And then, meron yung R. Okay, R1. And then, meron tong R2. And then, meron yung R3. Okay? So, kung ilan man yon, so yung pinaka-torque natin, okay, that would become equal to P N, okay, R N, okay, so that would be the summation. Okay, so parang ito lang naman yung sinasabi doon. So you have there the summation of the force P and then the R or the radius mula doon sa pinaka-center. Okay, so I'll give one example for this one, pinaka-basic example lang muna. Okay. So, a flange bolt coupling consists of 820 mm. Okay, so parang yung pinaka-drawing pala natin, ano? 1, 2, 3, 4, 5, sorry. Siya pala is 8. Okay. So, sige, gawa tayo. So, parang meron ka daw dito. Let's say, you will be having here. Okay. Tapos, meron kang 8. 1, 2, 3, 4, 5, 5, 6, 7, 8. Okay. So, ayun. Meron ka daw 8, 20 mm diameter. Okay? And, nandun daw siya, okay? They are spaced evenly around a bolt diameter. Okay? So, in short, from the center, okay? Yun. Ang kanya daw radius mula dito hanggang doon is around ilan? 300 yung diameter, so this would be 150 mm. Okay, ito yung tinutukoy niyang diameter doon. So mula dito hanggang doon, yun. So that is the 300 mm diameter. Okay? Now, the allowable shearing stress is 40. Again, ito ay Newton per meter square plus mega. Okay, so ibig sabihin, itong part na to is in Pascal and then you have the mega. So in short, that is just equals to 40 mega Pascal. Okay? Kapag same lang yung distance, okay, pare-parehas lang naman silang 150 from the center, ano? So, iisa lang yung, kumbaga, capacity ng kada isa. So, yung P natin, that would be allowable multiplied it by the area. So, we have here 40. And then the area is pi over 4 multiplied by 20 squared. So, this is now the force in Newton. Okay, so 40 times pi all over 4 times 20 squared. So, you can have it as 12,566.37 Newton or equal to 12.57 kilo Newton. Okay? So, para makuha natin yung capacity which is the torque T, we can have it as summation of Pn and then multiplied it by the Rn. So, yung P natin, so that is 12.57. And then yung R natin is para maging meter, para kilonewton meter tayo. So, 0.15 meter. Okay? Again, summation siya. Since pare-parehas naman silang ganito yung formula, 1, 2, 3, 4, 5, 6, 7, 8. So, i-multiply na natin by 8 volts. Okay? So, you can have it, the torque, which is equals to 12.57 times 0.15 times 8 volts. So, you can have it as 15.084. Again, you have here kilonewton meter. Okay? So, you can have this answer. Okay? So, that is the very basic, no? So, nanggaling lang siya sa concept ng shearing stress. Okay? Kaya lang yung shearing stress natin, or yung shearing stress natin, pag multiply by area, that would be a shearing force. And then that shearing force would act perpendicular dun sa ating bolt center. So, that is 1 torque, no? Eh, 8 sila, so we multiply it by 8. Okay? So, sige po, copy muna for a while. So let's have the next problem. 620mm diameter rivets fasten the plate to fix the member. Determine the average shearing stress in each rivet. Okay. So, for this kind of problem, sabi nga natin, from the center. So, dapat alam natin kung nasan yung center ng bolts. So, for this one, we all know na nandito yung ating center. Okay? Kapag hindi, you will use the Varignon's theorem, okay, in your statics to find for the center of the area. Okay? Now, from here, okay, magtutulong-tulungan lahat ng bolts, ano? Okay. Pero since hindi na siya circular, okay, mahihirapan na tayo. Pwede natin gamitin yung principle ng shearing stress natin na T rho over J. Okay? So remember, we have here the shearing stress, no? And we can have it as T rho all over the J. Okay? For this one, yung J natin, again, sabi natin that is the second moment of area. So, ibig sabihin yung J natin, that would be summation of the area multiplied it by the rho squared. Okay? So, unahin natin, ito kasing apat, okay? Lagyan ko ng naming, ano? Bolt 1, bolt 2, or rivet 3, and 4, they are radially equal. Okay, so ibig sabihin yung distance nila doon mula sa center equal naman. 75 tapos ito 50. 50, 75, 75. If you imagine, ano? So it means yung apat na bolts ko may isa lang radius na 1. Okay? So that I will have the J equal to apat na bolts, ang area niya is pi all over 4 multiplied it by 20 squared. Okay? And then, ang radial distance niya mula dito, okay, is square root of 75 squared plus 50 squared. Again, this is the second moment of area, so you can have it this squared. So, you cancel out this one. Okay? Plus, aside from that, itong dalawang bolts ko, which is volt 5 and bolt 6, again, they are equal. Ano yung radius nila, ano yung distance nila mula dito hanggang doon? So, that is equal to 50. Okay? So, you can have it as 2 multiplied it by pi all over 4, 20 squared. Again, ang distance niya, ang rho niya is 50 squared. Okay? So, mula dito, no? Rho squared. So, you can have it the value of J. So, the value of J would become equal to, okay, i-store nyo na sa calculator nyo, no? So, 11.781 times 10 to the 6. Again, it should be mm to the 4. Okay? Now, since the bolt on the 1, 2, 3, and 4 are all equal in distance as well as the same sila ng diameter, on the rivet, sorry, bolts ko ng bolt, rivet pala. Rivets 1, 2, 3, and 4, they will have the same average shearing stress. Okay? Again, the formula would be T rho all over the J. What about the T? So, yung T is the moment created by the force. So, this is a couple, 40 kilonewton. So, gawin ko siyang, para maging mm, 40,000. Okay? And then, its moment arm is 150. Okay? 75 plus 75. So, you have that. Okay? Again, the rho would be 75 squared plus 50 squared. All over the J, which is 11.781 times 10 to the 6. So, you have here the stress for bolts, rivet 1, 2, 3, and 4 times 150, the square root of 75 squared is 50 squared over, so you can have it as 45.91 again in mega Pascal. Okay, so you have here for the rivets 1, 2, 3, and 4. Okay? So how about for the rivets 5 and 6? Again, you can have the shear stress. Again, T rho all over the J. So again, ang T natin, 40,000 times 150. How about the rho? So mula dito hanggang dun sa bolt, that is just 50 all over the J. So ang J natin is 11.781 times 10 to the 6. So you can have it, the rho, the shearing stress, 40 times 10 to the 3 times 150 times 50 all over the J. Oops. Mali. 40 times 10 to the 3 times 50 all over the J. So you can have it as yeah. Ay, naka 400 pala ako. 40 times 10. Okay, so you can have it as 25.46 mega Pascal. Okay? So, these are the average shearing stress for each rivets. Pag ang tinatanong sa inyo is maximum, so this would be the maximum and this would be the minimum. Okay? So, if you will notice, okay, if in case pare-pareha sila ng diameter, yung mas malapit, yung pinakamalapit na rivets, siya yung nagkukuha ng pinaka-minimum na shear stress. Okay? And then yung pinakamalayo, siya naman yung nakakakuha ng maximum. Provided that they have what you call this one? They have the same diameter. Okay? So that is the answer for this problem. so a plate is fastened to a fixed member by 420 millimeter diameter rivets. Compute the maximum and minimum shear stress developed. Okay, so same thing yung ginawa natin kanina. So what we will do is to get for the shear stress, okay, we will be having here the T rho all over J. Okay, so unahin muna natin kung paano kinocompute si J. So sabi natin that would be the summation of area and then rho squared. Okay, so iname natin ano. So we have here again the bolt 1, the bolt 2, the bolt 3, and then the bolt 4. Kung papansinin natin by symmetry, alam natin na nandito kagad yung pinaka-center ng bolt, ano? Okay, ayan, nandyan yung pinaka-center. Okay. So, mula dito sa pinaka-point na to, which is the center, yung bolt 1 and bolt 4, same lang ang distance. Okay? So, pwede kong sabihin na dalawa yung area na yun. So, again, that is 20. So, pi over 4 multiplied by 20 squared. Okay? And then, ang distance niya mula dito sa center, papunta dun sa bolt, is 150. Okay? So, ayun, mula dun hanggang dito, you can have it as 150. Ayun din, mula dun, that is 150. While the others, 50 lang. Okay? So, squared. Plus, again, dalawa ulit na bolt. So, for the bolt, okay. So, ito ay for bolt 1 and 4. So, you will be having here 2 multiplied by pi all over 4 multiplied by 20 squared. Again, you can have it as 50 squared. So, again, this one is for bolt 2 and bolt 3. Okay? So, we will be having here the J is equal to 2 times pi all over 4 times 20 squared multiplied by 150 squared plus 2 times pi all over 4 times 20 squared multiplied by 50 squared. Okay, so again you will be having here 15.71 times 10 to the 6 mm to the 4. So ilagay ko siya sa calcu ko para sakto yung aking sagot. Okay, how about the T? So, ang T natin is 16 kilonewton. So, that is 16,000. And then, i-multiply natin by the distance. Okay, so that's 300 since this is a couple. Okay, so you can have it as 16,000 times 300. So, that is 4,800 times 10 to the 3. Again, this is in Newton millimeter. Okay? So now, since equal yung distance ng rivets 1, okay, and 4, and sila yung pinakamalayo, so we expect this to experience maximum shear. Okay? So ang ang shear max natin is T 4,800 times 10 to the 3. And then ang rho, ang distance from this center papunta dun sa bolt is 150 all over the J. So that is 15.71 times 10 to the 6. So you will be having here the maximum shear stress. 4,800 times 10 to the 3 multiplied by 150 all over the J. So you will be having the maximum of 45.84 megapascal. Okay? So yung bolt na pinakamalapit sa kanya, siya naman ang makaka-experience ng minimum. And that's the bolt or rivet 2 and rivet 3. So again, it should be on the minimum shear. Okay? So minimum is equals to rho T 4,800 times 10 to the 3, and then we have the rho, which is 50 all over the J, which is 15.71 times 10 to the 6. So you will get the minimum shear to be Okay, so that's 50. Okay, so that's around 15.28. Again, this is in megapascal. Okay, so that's it for the um, stress or shear stress experience by the bolt in the shaft. Okay, so ito yung torsional coupling natin, no? So flange coupling ang tinatawag natin. Okay, so the idea is still a torsion, it's zero all over chain. So that's it for the torsion, and we will close now the topic for the torsion, and then we will move on the next topic soon for the helical spring and shear and moment diagram for that case. Sige po, copy.